So what are intermolecular forces? Intermolecular forces are forces between molecules. The prefix inter means between. Intermolecular is between molecules. We can generalize it to be between particles because we're not always dealing with a molecule. Let's contrast that with something called intramolecular forces. Now, you've already studied intramolecular forces, whether or not you called it that. The prefix intra means within, so these are forces within the molecule. These are bonds. An actual honest-to-goodness bond between two atoms, a covalent bond, is an attraction within that molecule, and we've studied that before when we've drawn pictures of us. These are Lewis structures. So in chemistry, an intramolecular force is a bond within a molecule. That's not what we're talking about in this chapter. In this chapter, we're talking about intermolecular forces, which is the attraction between two different particles in a sample. So now we have more than one of these molecules or particles, and we're looking at the attractions between the particles. And the reason why we're looking at these attractions is because we're going to discuss them in terms of why are some things solids, some things liquids, some things gases. Why does that occur? So let's start talking about what the intermolecular forces are. The first one I want to look at is something called dipole forces. You may recall when you studied Lewis structures that you talked about the fact that some molecules are polar, which means they have a dipole moment, and yes, you still need to remember that. For example, let's look at the molecule HCl. Now, we're not talking about hydrochloric acid. I want the pure substance HCl. That means I have the covalently bonded molecule, hydrogen and chlorine bonded to each other, and the Lewis structure would have some lone pairs on the chlorine. The Lewis structure would look something like this. As a pure substance, if I had a jar of HCl at this, right here in the classroom, it would be a gas. That means that it's going to look kind of like the picture that we had of the gas, where the particles were very far apart. Now, there are intermolecular forces. There are forces of attractions between the HCl molecules, and they are because of the dipole moments of the molecules. Recall from when you studied the Lewis structures that the hydrogen is partial positive, the chlorine is partial negative because of the electronegativity differences. We can represent that a couple different ways. On the top here we have our partial plus and partial minus drawn. On the bottom we have another way to represent who the partial positive guy is and who the partial negative guy is. And in a sample of HCl, we have lots and lots of these molecules floating around in our container. And all of these molecules are polar with a partial positive side and a partial negative side. We all know that what makes the world go round is the attraction of positives and negatives. And so what we see in this container of HCl is we see an attraction between the partial negative side of one molecule to the partial positive side of a separate molecule. In green, we see our intermolecular force, our IM force, intermolecular. This is our intermolecular force. It's between these two molecules, and it is an attraction between the partial negative of one molecule and the partial positive of the other. Likewise, we have an attraction between these two molecules, between the partial negative of one side of one molecule and the partial positive of a second molecule. This is also an intermolecular force. As opposed to the intramolecular force, I know I crossed it out, but let me point at it one more time. That would be the actual bond between the hydrogen and the chlorine. So the actual bond between the hydrogen and chlorine is our intramolecular force. It's within the molecule of HCl. The green dashes, and we usually do represent them as dashes, a dashed line, I should say, rather than simply one dash. This ... dash line is an intermolecular force between two different molecules. Now, the stronger this intermolecular force between the two molecules, the more likely these two molecules are going to be closer together. So a weaker intermolecular force will allow those molecules to get further apart, The stronger intermolecular force is going to tend to pull them closer together. That force of attraction will pull them closer together, and so you can start to see sort of take shape what the difference between a solid, a liquid, and a gas would be. This intermolecular force in green is called a dipole force. Sometimes we refer to it as a dipole-dipole force. We actually say it twice because it is between two different molecules which both have a dipole moment. So this is an example of a dipole force.